Hi, this is Big Geek and I'm Dan. Welcome back to the workshop. Well, you saw the thumbnail, so you know what I'm trying to do, and that is to fit the cross-slide DRO on my Warco mill. I made a video a couple of months back where I put the long rail on the back here, and at that time the DRO scale I'd ordered for the cross-slide had not arrived, and it basically didn't arrive, and I ended up getting a refund and ordering again. But I probably should have realized when I got the first one that the type that I had ordered were not going to get kind of scalably smaller with length. They just come shorter. But the actual package they're in doesn't really change size. So when it did eventually show up, my short DRO scale came like this. Now you may see a problem here. This is supposed to fit on here somewhere. Now I believe when Warco, if you buy them from Warco with them fitted, they come somehow mounted on the back, and they obviously have a low profile DRO of some kind to fit there. But pretty obviously this is not going to fit. Now I thought about a bunch of different options, like could I somehow mount it underneath with some kind of complicated contraption? But no, that was clearly not going to work. I did think maybe I should just give up and try and find a low profile one. They get quite expensive, the small low profile scales. And certainly to fit the system I already bought, like I know that this is compatible. I mean, they broadly should be the same, but apparently there can be differences in the wiring. So what I did, as you'll have seen from the title of this video, is take this apart to see what components actually are and how big this thing really needs to be. So let's go over to the workbench and take a look at that. So yeah, I have actually already taken this predominantly to pieces. Broadly speaking, there's not a lot going on inside, so let's take a look at the two key pieces. And I've already got them in some place. So this is the magic. This is the glass scale that gives the glass scale its name, and people can and do cut these down to length. They obviously just chop them off. And broadly, I think, you know, there's just an insanely dense number of fine lines at the whatever accuracy you bought at. This is a 5 micron scale, and there is a reader head, this thing, which has got some bearings on it, and obviously some kind of, I guess, LEDs and optical sensors in order that this runs in here, and it is set up to be able to read the dashes. So now that profile, hopefully you can see, is a lot less chunky than that profile. And actually, even when you look at the length of the thing, now obviously this is designed to allow a reader head to run the entire length of this scale to give you that full reading. I don't actually need the entire length of this scale for my cross slide. This was just the shortest one I could find in stock. So, as you'll have gathered, I have been designing and 3D printing parts to try and reproduce enough of what that looks like to be able to use it. So let's have a look. So this pile is the indicator that this stuff does not happen quickly. We've had failed prints, we have different designs, things that were not quite the right size, too close together, not close enough together, etc., etc. There's been a bunch of different things. Now the basic design of this, the kind of where the scale lives, hasn't changed much, and I stole the way they do this in the aluminium channel, which is this hole is quite wide, and then they have a bunch of these little slightly soft rubbery bits that they stick in, which take up the slack, which I guess means that you don't have to have such a precision channel in order to get kind of the result you want, in terms of keeping that sort of firmly in place and kind of vertical connected to that. So that's been a part of the design for a while, and here we can see that I've connected together a few pieces. Now I designed these to essentially glue together, because I'm trying to keep this overall thickness really down and fasteners take up space, and most of the time it doesn't really matter, it's just going to be connected together. So let's have a look at this. Is designed to be the other side of this, and it just aligns on some notches there that will ultimately be glued in place. And so this is the profile that I'm trying to keep to. So it's still as tall as the main aluminium channel there, but this is for everything, including this lip at the top is a chip guard. So this is going to sit like this. So if we come back over here, now I'm trying to keep this kind of the same thickness as the cross slide itself. Now I've also decided that since the Gibbs screws for this are over here, and one of the problems I understand with the Warco version is that that blocks all of these off, I'm actually designing this to go on the front here, which is in theory it means it gets in the way a little more, but hopefully you can see. How much can you see? Almost nothing at all. Let me do that with this camera. So yeah, basically this enclosure is designed to fit on the front here, tucked up, and it will be flush. Oh, it says that's not glued on at the moment. Basically, it's going to be flush with the front here attached. And then obviously this overhang is the chip guard to hopefully prevent any detritus getting in. And then the reader head piece will sit down in this trough here and use the mounting holes for the follow steady as what kind of holds the reader head in place. And that means that the wiring and cables can come kind of down through the bed, and hopefully hopefully that'll all work. That is sort of the plan, and you join me in my timeline, having just about gotten to the point I'm sort of semi-convinced this could work. So let's go and have a look at kind of the pieces. So the critical part, and there's another version of this printing even now, is the carrier that matches kind of this part. So still inside here, connected to this cable, is a little circuit board, which this is where the ribbon connects to, and then that is wired in to the connector. I need to desolder some points in order to get the circuit board out and pull this out, but I think that will be fairly straightforward. The circuit board will in here, and the way this sits, that ribbon comes up into that tray, and this little carriage sits kind of here between these two guides, and this little spring-loaded fella pops into a hole and a groove here that gets screwed down, and the entire job of this piece of metal, this little spring essentially, is to hold this, kind of pushing a little bit up or down or whatever onto the glass scale and over to one side to keep the read head against it. So that provides that, and it also is the kind of the primary mechanical connection, which means that when this bit moves exactly in lockstep. Now, it may seem a little bit kind of janky making all this precision machinery out of 3D printed parts, but really the key component for these DROs is that these two things need to move at exactly the same pace relative as the physical cross slide moves against its piece. And as long as you can, you don't introduce too much friction or any kind of slop, then as long as this will move rigidly with the carriage, or actually technically the way I'm doing it, it's the scale that's going to be moving with the cross slide. As long as that kind of moves exactly 1 for 1, then this should do the job. Now, I have another version of this printing right now because actually these 2 holes are intended to be the ones that screw into the follower steady holes, and they're ever so slightly too low. We're dealing with very, very fine tolerances in terms of space requirements. I have to keep the overall dimensions of this so that it's sort of not, well, I want it so that it doesn't come outside the envelope of the normal cross slide itself anyway, and obviously it can't be more than 16 mil high to fit underneath everything else that's going on. But when that's together, this basically rides in here like that. So you'll have the glass scale in here, this held in orientation, moving up and down, and this will be attached. Now, the other detail, as you'll see from this, is that the aluminium scale has these little yellow rubber wipers. Which it actually has 2 pairs of them, that the reader head kind of has a, essentially they fit in this gap, right? Just to make sure that, again, any particles don't get in. Now, I think I should get away with probably not having these at all, because again, it's going to be oriented this way, chips are going to come like this, they'd have to kind of come up, under and in. Hopefully that's unlikely, but I have designed a feature into the 3D print for the wipers to fit into. So I don't know, let's see if I can get you a zoom. So this is one of those things where the strength of 3D prints is quite interesting. So this is PETG, and you can see how thin I've managed to make this profile. Like, it's so thin you can see through, see light through that thinnest part, and that rail there is ever so slight divot for these little feet to run in, just to try and keep it in orientation like that. But the tiny little feature I wanted to kind of highlight here, if I can get it to focus on the end, you can just about see, like, that feature is almost too small to print. In fact, when I print most of my things, I print them at 0.3 mil layer height, and the default settings don't even slice this as a whole thing. You have to switch on some options to make it print. But once it is printed, it is sufficiently rigid that you can actually pop these yellow wipers into place. Now, again, I've had to cut, so they come with like this much material on them. I've cut it down because I'm reducing the space. I don't have room for that whole thing to exist. But there's one of these rails on each side. So when fully assembled, I should be able to still have a certain amount of that rubber seal going on. And then how am I going to attach it to the lathe? Good question, I'm glad you asked. So this guy, is this one of the good ones? This is the good one. This is an end cap, and so there's an end cap already glued here. This guy goes on this end, so as he's connected there, as you can see, it just exposes a little hole, and that will, so I will drill and tap a hole into the cross slide there that will screw into, and then if I put this in place for a second, I have another piece like this, which is just enough to hold over, and so this will go on the other end of the cross slide. And again, I will glue this onto the plastic and then drill, tap and screw that into the cross slide. So this is still overlong, it will overshoot the back. I could, again, I don't need the whole glass scale, I could cut it down. For now, I'm just going to see if I can make this work without changing anything. So this will overhang the back, but I've got plenty of room at the back. I've extended out the kind of the backslash anyway. And this distance, I say, just means that it doesn't quite clear kind of the front feet, if you like, of the carriage that moves up and down. So that's the design. All I need, I think, is the fixed version of this, and then I can desolder the wires off of the circuit board to clear this out, so I can unscrew this connector, get the circuit board, put the circuit board in here, resolder the wires. There's a hole through that edge, you can see that. So hopefully in the new orientation, this cable will come up through the base, through the center of that travel. Now, I do have to worry a little bit about the fact that it's not a completely clean slot through the middle of the lathe bed. There are partitions, but I think 90% of the motion that I use is clear, and I hope that there's enough flex in this and enough distance that it will be able to pull past those enough. We'll see. And if it doesn't, it doesn't. I mean, got to experiment with these things. So I'm going to go upstairs, get the new version of this, we'll put it together, and then we'll see whether or not we can assemble something of a first pass. Let's do that. Right, so here's the new batch of parts. So now I printed them as 3 separate pieces, and so I even split this rail down the middle, and that's to make the printing a little bit faster and easier. The only other option would be to print it as a whole piece, but then you'd need support for this whole chunk. So in order to just make the whole process much easier, just print the two, and I can stick them together. And then you can see there's a little detail on this one. If I can get you in for this. Let's come into there. So there's precise little detail here of this little notch and hole. This is for the spring piece to go into, so we'll do that in a sec. But for now, I'm gonna glue these two halves together, and then these two together glue in onto the rail. And to do that, I have been using Starbond medium super glue. Starbond were kind enough to send me a selection of their glues to try out. They are now available to order for the UK and from a site. I even have an offer code and a link, which I will put in the description below, if you are into buying super glues. Now, I find that it solves a lot of problems that would be a lot kind of more expensive to fix in print time. I say I could have printed this as a single piece. So rather than add hours of print time, we can just quickly, now let's see, which way around do I want to put this? I need to put it that way around. So we'll just whack a bit more on here and here, and I want to make sure I get this edge as well. Now, obviously, I'm very grateful that Starbond sent me some glue. I find it super useful, and if you do want to, if you find yourself buying super glue, I would suggest you buy them from Starbond, mostly just because, hey, any company that wants to kind of support my little channel with some kind of goods to try out. That's cool. That is now nice and solid. Let's see about this assembly. So we will put that in there. No, wrong way around. That goes in there, down the side, and then this should, there's a little through hole there, and I need a little screw. So for this, I basically just mimicked the exact kind of layout of the existing carriage. So that should hold that like that. So you end up with this like waggling around on the end of this, but I say what that does do is it gives it a little bit of down pressure and a little bit of to one side pressure, which holds the relevant part in the correct orientation. So let's pull that off a sec. Let's bring our glass scale back to the way it's supposed to be, which is in this version, and we'll just pop a little retaining whatnot in place. In a bit. Right, so that's holding our scale in orientation, and then this guy should come over here. This is a little bit fiddly. Right, so as you can see, that is now in place. So I should be able to attach this on this end. Let's see if I just pop this back into its runner. If I put this clip there for a sec, just in the middle. So this is what the whole kind of assembly kind of looks like. I don't know for sure that this is going to stay as flat as I need it to, but this does roll up and down. There's a little bit of friction to it, but I think, you know, the cross slide never really moves very fast, and it probably will not add a noticeable amount. So the next real question is whether these alignment holes are going to fall in the right place when the whole thing is kind of sat where I'm expecting it to be. I do need to trim that wiper. Technically I could have a wiper on the other side as well. I need to trim that one down. Let me do a few bits more tweaking off camera, and I'll bring you back when I'm ready to do a test fit on the lathe. Okay, so it's a couple of days later and we're back at it. Some of that has been a lot of reworking and retinkering. Some of it has been because I got a VR headset and it's pretty cool. So where are we now? Let's take a look. So last we looked, this was the version of Carriage. At that time I still thought that the cable would come through here and it was still relatively tall. I thought I was going to wire things underneath. That we scrapped that idea. Then we moved on to this, which is pretty close to the final design. I dropped the standoffs lower so the circuit board sits lower. I cut this whole thing out so that I started developing these little modular connectors which would sit in the middle to provide the wire, because I knew that I needed this to be able to screw on to the end of the kind of the metal fitting, the metal snake. Let me grab the thing. I knew that I wanted to, this would need to screw onto here, and I couldn't do that whilst that was in there if this was also then going to be soldered on. So I was like, well, if if I separate it all, I can screw this on, solder the wires, then screw everything into the board. Initially, I again went with the straight. Then I realized that actually when this is kind of on the carriage, having this come out straight out the back interferes too much with the bed, and I needed to angle it. So initially I went with a shallow angle and eventually a much steeper angle. So this was the last version that I printed, so that went in there, and so that angle was pretty good. It kept everything clear of all the mechanisms, and I almost went completely live, kind of used this as the final, but this was a little deeper than it needed to be. I didn't, there was sort of an old idea kind of imbued in this, so I decided I would actually bring this whole thing up a little bit. And oh yeah, the other design feature of this version, and actually it's probably easy to see in the new thing, I cut this little notch out where the legs come into the carriage, so that when they are in the carriage there is this extra kind of space, and that is because where the circuit board is now going to sit lower, this attachment for the ribbon needs to actually be able to essentially come through the bottom. This is all in service of keeping this overall thickness down, and like stealing that space from anywhere I can get away with it. So this now is shorter, and this is commensurately shorter. This will fit in like that. The other thing I made off camera was an actual metal component. So this is the stud that is going to attach it to the carriage. So this is an M6 end with a machined hex head. I initially thought I'd use both, and maybe eventually I will, but actually it's pretty solid with just the one. So this guy pops through here. This is the exact space that I want off of the carriage. Right, that all said, obviously that meant that I have once already resoldered this circuit board, risking destroying everything because I'm not great at soldering, and then I had to desolder it, and I'm going to resolder it again. But I have seen it working once, which is good. So that's where we're at. This is the final design. So I'm just going to get all this together, refit the circuit board, resolder that points, and then we'll go over to the lathe and I'll talk through fitting it up, and hopefully that'll be that. All right, so that is resoldered and screwed back in. I did cut I modeled a notch in the tray here because this needs to be pretty flush. I have ummed and ahed about like 3D printing a lid for this. For now, I'm actually just going to use gaffer tape. Basically just something thin that I can stick over that will protect it. But yeah, I'm trying to minimize unnecessary parts if I can. So now that that's attached, we can reattach the carriage piece. The reader head, I should say. So that should just pop into there like that. What I have been doing is actually, because there's excess ribbon here that isn't really required, so I've been tucking that, folding that back on itself somewhat. And we can reintroduce this guy. So let's just get the threads. So these small holes are not tapped or anything. the plastic is sufficiently soft that when sized to the right kind of hole, you can just screw the screw in and it essentially taps itself. Which is very convenient. Okay, so I think that's that all reassembled. So here's our track and our glass scale. Now I keep handling it, so I do have some glass cleaner here just to try and remove my smudgy fingerprints off it. I don't know that it will make a huge difference to the reader, but it might. Try and get the underside of that as well. Now I did discover in testing that whilst it is difficult to tell with the human eye, that this is sided. So if this is flipped the other way around, the reader does not work, or at least it doesn't work reliably. So if you're going to do this sort of crazy thing, then you do need to pay attention to which side it is, or just accept that you might have to trial and error your way to flipping it back to correctness. Right, so let's pack this back in here. Oh, come on, tuck those under. This is one of those fiddly operations because it's sprung and it's got very little space to operate in. Ah. I'm trying not to trash everything. Okay. So that carriage back in and running. A little bit fiddly getting this back together. Now I'm not going to glue this bottom piece on, I think. It will be held in place via the notches and by the fact that it's going to be screwed down. Okay, so kind of ready, I think, to try and fit this to the lathe, so let's go over there. Really need to be better at keeping up. Right, so this is geared up. If I wind the carriage all the way back to here, then for the various partitions that exist in the lathe bed, I can fit that down like that. All the way. Okay. There we go. And that thread is designed to bottom out at the right place. Let's stick get that. Goes in here. This end cap goes on there. Let's give it a try, shall we? So this plugs in back here, and moment of truth. Hey, we have a working DRO scale on the cross slide, and it doesn't take up all of the room in the world. It takes up quite a bit of room for sure, but if I bring it, I can get all the way to about here, which seems plenty of forward travel. Does deny me that last little bit, but we'll see if that's important. But here we go. Now let's just pretend that there wasn't like a whole day between me attaching that just now in your time and this all working, in which I had to spend hours rebuilding the circuit board because I had stripped some of the contacts apparently when I resoldered, desoldered, resoldered, etc. Took a long time. It was fraught. I thought I had completely destroyed it. But here we are, back from the brink with a working cross slide DRO scale. It fits. It works. How cool is that? I'm so happy. I'm so happy to be finishing this weekend with this not a disaster. I'm now out of time for actually trying it, but I will use it in future videos. But for now, I'm going to wrap this and try and get this edited and up today. Thank you for watching. I hope this has been, I don't know, somewhat educational, useful, considering how much time and pain went into this today. Thank you for watching. Hit the subscribe button. Comment whether or not you think this is a remotely practical DRO implementation. And otherwise, I will see you next time.